So today we'll talk about streams. What are streams? How you can use them in your event store? What's the purpose of the stream? And what's the difference between global stream and, well, the other one? So we'll talk about the task that the task model that we talked already in the previous video. You can probably find the link somewhere depending on where Tomek will put it. But Tomek, will you introduce us to task once again? Just a quickly reminder what this model is about.
Yeah, so it's a very simplified model. We just created that for the demo purposes to explain all those concepts in an easy way. So yeah, the model name is a task. We have the comments which are the methods for that model, like create, change name, assign date, complete, reopen, delete. And on the right hand side, you can see events that this model emits. And as we said, that's just a simplified model for the demo purposes, right? And it's like when you, for example, change the name, we send we publish the name changed event. Or when you assign the date, we send the date assigned event, and so on. And today, based on just those events, we will try to explain you the concept of streams. If you recall, we also have it in the code in our GitHub repository, so you can see that when we publish some events, we always use the stream name, which is the name of the model, $, which we also explain because that's some kind of our and not only our convention, right, Lukasz? And then UUID.
Yeah. Exactly.
Yeah, because you have to somehow be able to somehow find events that are connected to specific model. We don't say aggregate because we don't use it only for aggregates. We say model, right?
Yeah, exactly. And later in this video, I think that will show you one of the fuck-ups that I did recently when it comes to naming streams. And this is totally not about the aggregate. It's just keeping events in streams, but we'll get into that. And I think it's a good time to ask a question, what is a stream? And I would like to explain that because I've spent some time thinking about that. And stream is just this logical place where you can put your events. So you know, as Tomek mentioned, that you have to somehow know which streams belong to which class, which aggregate, which model, and so on, etc., right? Which business concept. We, of course, distinguish this business concept by some ID, but we need to have this information in the event store, right? So we have this in streams. Streams are logical representation. They kind of keep the information about events and are logical order for those events, how they occurred.
Yeah, I like actually how you name that it's logical, right? Because yeah, you have like the representation of it in the database, right? In the streams table where you have the name, but actually when you look at it on our Miro board, you can see that it's really like logical representation, right?
Yeah, exactly. As I told you, I was thinking about that. So would you like to explain what are those lines, except the time? I think everyone knows the time, right? We usually draw the time from left to right. But besides that, can you tell us what is the global stream, for example?
So in global stream, we have all the events that occur in a specific order, right? From left to right in time, and they are like all events that occurred in the system, all events that you store in your system, and then some of them belongs to different models, and you can see like two different streams here for the task model. So those are actually two separate objects, right? And the first task has some events that belong to this object, and another task has other events that belong to the second object here. And
so they are like logically correlated, right?
Exactly.
Okay.
Exactly. And then based on if you want to reply the events and you want to get the state of the specific object, so this one or this one, you have to refer to the stream of the task and take only those events that are correlated to this object. And you simply apply one after another. So you get the current state of the object. Would you like to add anything, Lukasz, here, or?
Yeah, just maybe simple example that if we start reading this stream from left to right, we would first obviously create a task. It would just have ID in our implementation. Then if we would name it to, I don't know, something, then we assign the date, and then we complete this task, reopen it, and we change the name to, let's say, user story 1, and then we complete this task. The last name obviously will be user story 1, and the task status at the end is going to be completed. So if we have some kind of read model, if we have this task visible in the UI, it will have those specific properties, let's say. Erasing my dots.
Cool, thank you.
No worries.
Yeah, so actually this one event reminds me about something I think we wanted to tell about, but we can just mention that in standard project, when you, for example, want to delete the object that you store in the database, so the snapshot version, let's say, you somehow call the delete, destroy, or whatever you call it method for that object. And in event sourcing, you can do it, you can delete actually the object, like this one task with the specific ID, in two ways. Basically, you can remove the stream at all if you don't want to have any reference to that object, but you can also have like last event that tells that the object was deleted, so like task deleted, right? And then when you read the state of the object, you can, if you see this kind of event in the stream, you know that the object itself was deleted, right? So it depends how you want to handle it. I don't know whether you want to raise any exception or or return nothing, actually, right?
Yeah,
but
so
yeah.
If you have some read model, for example, it may be if the read model is built from the events, which it should be, by the way. If your write model is event source, then you can, depending on the strategy, you can either mark this task as deleted in your read model, or you can just remove it from your relational model, because that's how we usually build the read models. And once you do that, then it will not be visible anymore in the UI, if that's your intention, of course. And as Tomek said, you can always remove the stream. I don't like that approach really much, but also if you remove the stream, remember that those events, they will be still in the global stream. In Rails event store, but I also think in other event stores, at least most of them, there is no API that would allow you to remove event from the event store, right?
Yeah.
Sorry.
And now I'm praising your lines.
So if you want to remove the events, obviously you can hack it, but it's not really nice. And then, of course, you lose this auditability benefits of event store that we talked about. So if you're ever audited by some I don't know, government or whatever, then you're not really reliable anymore. So the decision is up to you, as always. Right? Yeah, we don't recommend that. We don't ever delete events. If we don't need them, we just detach them from the stream and just let them be. Maybe they'll be needed later on. All right, but there is one more thing we would like to talk about, right, Tomek? If we would move down. So there is one thing that we didn't mention in previous video, or maybe we did, I don't remember exactly, but we were saying that in Rails Event Store, there are two tables for, let's say, storing events, quote unquote. So the one is the event, the table that holds the events, right? But the other one is the events, the table that holds streams of those events. And the reason it's done like that is because compared to other event stores, in Rails Event Store, we don't force you to publish an event into a stream. So for example, you could have an event that is only in the global stream, but it doesn't belong to any other stream, right? It's not here and it's not here either. And we have a couple of those events right here. Actually, that's only 3. It's not a couple. So yeah, so this is the possibility that you have in Rails events, so we can always do that. But when it's a good solution, Tomek?
You mean when we don't attach them to any stream, right?
Yeah, exactly.
I mean, we always can have them in the global, right? So it's important that we have them. We publish them for some reason, but then if we actually want to have them in the stream, we can include them, right? We can rewrite the stream, right?
Yeah, exactly. We could just read all the events of certain type, or even read this stream, let's say the first task, and then we would have to make decision how to where to put this event in the stream, right? Because obviously you could say it could go here by create that date, but it's not so simple. You would have to make like there has to be a conscious decision in where you want to put this event, but that's maybe less important. The important thing is that you can always rewrite your stream, and you can reattach the events. You can drop some events if you like to. That's actually one of the strategies that you can use for when you have introduced some issue and you have an event in stream that shouldn't be here. But you can also do it differently. I think we'll talk about that in other videos.
Yes. And it's always good to have, I think, more events even if you don't connect them to any streams, right? They are in the global stream, but and you don't have to assign them to streams, but to explicit dedicated streams, let's say. But you always have them in the global stream, right? And you can actually read from the. You don't have to do it because there is a huge number of events in the global stream, but you can always do it, right? If you really need that.
Yeah, exactly. We often use this approach for technical events, right? So we also use Rails event store as a pub/sub mechanism, but there's this small distinction that we always have the handle to this event. We can always find it. We can correlate with tenant, and also we could, that's actually what we do very often, we correlate certain events with tenants or user streams. So then we can see all the history that is happening in for user or for certain tenant, but I believe we'll make a separate video on that.
Yeah, actually we could even do the one about types of events, right? Yeah, I think we discussed that recently as well. That we have different types of events, and we, if you want, we can create an episode about this one as well.
Yeah, how do they say that? Give a like, leave a comment,
subscribe.
Subscribe. Yeah, then we'll do that. No worries. You can also email us. If you do that, then we'll definitely do that. We don't get that many emails yet. Okay, but let's talk about, I think, one last thing, because I'm seeing that as always will exceed the time. So I promised you some fuck-up stories. I know people like fuck-ups, right? So this will be really short stories, but it's related to the stream naming and what to pay attention to. So if you for a moment think about the onboarding process, right? If you go to like a new app, like a SaaS, they usually have these long onboardings that are helping you configure the application and so on, right? They usually have multiple steps. So what we did in our app, we did create a stream for onboarding. So obviously it started, the name started with onboarding. We use $, that's just convention. You could use any other sign that you would like. Sorry, I had a battery issue, so I'm back. You can see that I changed my style a little bit, but going back to the stream naming. So as you can see, I started with onboarding and giving the ID right after. And this user ID, it was just database generated ID. So for example, our stream name looked like this. And I had a couple of events, and that was fine for a moment. But then I realized, for some reason, which I will not talk about, is that I decided to change it to tenant ID. Obviously, what I did, I wrote a script which removed all those streams and then found the events and reassigned them. So it was fine. But then, and I talked to Tomek, and then he mentioned that this is a little bit confusing name, and it was really good timing that we had this discussion before this episode, because I totally agree. I mean, it is unique, right? We shouldn't have the same tenant IDs. But if you look at this stream name, it doesn't tell you anything, right? So we talked about that, and I think, Tomek, you suggested to change the name to something like this, right?
Yeah, to make it more unique, right?
Yeah, exactly. To make it a little bit more unique and a little bit more understandable, even if it has to somehow, well, it's more explicit, right? It exposes some additional concept of tenant, but for the sake of readability, for the sake of understanding it easier when you look into Event Store browser, which we were showing in the previous episodes, I think it's worth it to just keep the name a little bit more clear for whoever. Yeah.
You also don't have any way of doing the conflict, right, between those streams, because you use the database generated IDs like integers. You actually don't know whether it was user ID or tenant ID. Maybe you could, for example, avoid removing all streams that you generated till now, just to use the tenant ID, right? Instead of user ID, you could simply start adding those with the UUID, for example, or like here with the tenant underscore and then integer, right? Because then you know whether it was actually for the user or for the tenant. Yeah, so we definitely recommend using unique identifiers after the $sign, if you use $sign.
Yeah, if you use the, so long story short, ID is not recommended.
Yes.
So what would be better is, as we mentioned, as I had this placeholder here, I very quickly generated this UUID. That would be much better, and then you could create some map, correlate somehow tenant ID, which is equal to 1, with this UUID, which is I'm not gonna even try to read it.
Yeah,
this part.
It was just a safety tip, right? Don't cross the streams.
There's something very important I forgot to tell you.
What?
Don't cross the streams.
Yeah, exactly. Yeah, and I guess that's all what we wanted to cover, right? Looking at my special card.
Yeah, I think we only wanted to mention about ideas for the next episodes, right? So you can, if you have any ideas or you have any preferences, we can tell about what, Lukasz? Because I forgot about concurrency, right?
Yeah. Optimistic concurrency with streams, how to do that, what options do you have, and even when do you have to take care about that, and even if maybe it's not even interesting to you, but I hope it is. And also, one last thing we wanted to mention.
Short stream, right?
Yeah.
The shorter, the better. Okay.
That's what she said.
Yeah, as in the conference, everybody will tell you, just keep the stream short and life goes on. But yeah, we actually want to create an episode on what's short, when the stream is too long, and what strategies you have. Of course, first in mind that probably most of you have is use snapshots, but our answer to that is, Tomek?
No.
Please don't. Please don't use snapshots.
Please don't.
It's just like a plaster when you have a scratch on your human body. It's just temporary. It's not a good solution for. It's not a good permanent solution, basically.
Yeah.
So
just a quick tip, right? That keep your streams short, and if you see them too long, maybe there are 2 models or 3 models that are under single stream, right? Because from our experience, it usually looks like if the stream is too long, it means that there is something wrong on the design level. Maybe there are more models than we think, right?
Yeah, exactly. Or maybe there's some closure that we need to make. But let's not go into it. I think, hey, let's create a separate episode for that. So right now, I would like to thank you for watching. As I mentioned, that was kind of a joke, but it would be really nice if you could subscribe or just give us some comments what you would like to hear about in the next episodes.
Yeah.
Right now, we are at the stage where we are willing to listen, but later on, who knows? So thank you very much for watching. See you next week.
See ya. Bye.